Assalamualaikum class. And good afternoon. So for today class, we continue with Thevenin and Norton theorem with dependent sources. So I already explained this one, the theory about this one in a previous lecture. So in order to get the Thevenin or Norton theorem with dependent sources, okay, you need to introduce either a voltage source or current source into the circuit. So we go straight away to the example. So in this example we want to find the Thevenin equivalent of the circuit at terminal AB. So if you look at this circuit, so we have in this circuit we have one dependent sources over here and then one independent sources over here. Due to the dependent sources over here, so in order to get the value of RTH, we need to use a different method, which is we need to introduce a voltage source or current source at terminal AB. Okay, so this is the solution. This circuit has one dependent sources, which is 2Vx, which is, if you see the circuit, 2Vx is actually voltage controlled voltage source. So to find the value of RTH, we need to set all dependent sources to 0. So that means you have current source. So you need to set the current source equal to 0 ampere, which is we open circuit the current source. But at the same time, you need to leave the dependent source alone. So that means we need to leave the dependent intact in this circuit. So therefore, the next step is actually we introduce an independent voltage source V0 equal to 1 volt at terminal AB. So then you need to calculate the current I0 through the terminal in order to get the value of R Thevenin. So R Thevenin can be calculated using this formula, which is RTH equal to V0 divided by I0. So V0 is equal to 1 volt. This is the voltage source that we introduced. So therefore our aims is actually to get the value of I0, and then automatically you can get the value of RTH. So in this example, okay, so I choose to introduce independent voltage source, which is V0 equal to 1 volt at terminal AB, right? So next, this is the circuit. So now we introduce V0 over here at terminal AB. You have 1 volt voltage source. So our I0 is actually a current that we get from the voltage source that we introduce. So this is your I0. So therefore our aims in this for this circuit is actually to find the value of I0, and then from there we can calculate the value of RTH, which is V0 divided by I0. Right. So therefore from this circuit I choose to use a mesh analysis, right? Okay, so in order to find the value of I0, if you see here, I0 is actually equal to I3, but because of the different direction, so we can say that by knowing the value of I3, so you can get the value of I0. So let's start. So by applying a KVL at loop 1, so this is our loop 1, right? So this is our loop 1. So you got negative 2Vx plus 2I2 minus 2 plus 2I1 minus 2I2 equal to 0. So we elaborate this equation. You got 2I1 minus 2I2 equal to 2Vx. And then you can simplify this circuit again. It become I1 minus I2 equal to Vx. Right? So in our equation now, we have a Vx. Right? So therefore, we need to know what is Vx, because this is a mesh analysis. So if mesh analysis, usually our equation need the unknown need to be in a currents, right? So therefore you need to know what is Vx from the circuit. This is our Vx, right? So our Vx is actually voltage at 4 ohm. So therefore V equal to IR, right? So but this sign for Vx is plus minus, right? Plus minus. So therefore we can say that from the circuit your Vx actually equal to negative for I2, right? So negative due to the I2 flow this direction will give you positive negative. So therefore from here we can see that the polarity is different. That's why you got negative for I2. Vx equal to negative for I2. Right? So by knowing this, you can substitute Vx. Okay, you can substitute Vx in this equation. So therefore you got I1 minus I2 equal to negative 4I2. And then by elaborate this equation again, you got I1 plus 3I2 equal to 0. So this is our first equation for loop 1. Alright, so next we go to the KVL at loop 2. So if you see, this is our loop 2. Okay. Okay, this is our loop 2. So from here, this is loop 2, guys. So from here we can write loop 2 equal KVL at loop 2 is negative 2I1 plus 12I2 minus 6I3 equal to 0. Okay, so this is our equation number 2. And then next we go to the loop 3. Loop 3, so this is our loop 3 here. So this KVL equation give you negative 6I2 plus 8I3 equal to negative 1. So now we have three equations. So equation 1, 2, and 3. Okay, we need to solve these three equations in order to get the value of I1, I2, and I3. So by using your calculator, right? So you got I1 equal to 0.166 ampere and I2 equal to negative 0.055 ampere and I3 equal to negative 0.166 ampere, right? So from the circuit, like I mentioned before, I naught is equal to negative I3. So therefore, I naught equal to positive 0.166 ampere. So from here, we can calculate the value of RTH, which is V naught divided by I naught. So which is 1 divided by 0.166 ampere. So equal to 6 ohm. So our RTH is equal to 6 ohms. Okay, so next, okay, we not settled yet. We need to find the value of VTH, right? So to get the value of VTH, VTH is actually V open circuit at terminal AB. So this is the circuit. We use this circuit to find the value of VTH, right? So if you see here, this is our VTH, V open circuit. This is our VTH. But always remember, due to the open circuit over here, so I at 2 ohms over here is always 0. So we can say that V open circuit is actually equal to VTH or equal to V at 6 ohms, guys. Alright? So we use the same method, which is using a mesh analysis. So I already put the I1, I2, and I3 over here. So from loop 1, okay, loop 1 over here, I1 is actually equal to 5 ampere, right? So loop 2, next we go to the loop 2 over here. So at loop 2, you got this equation, which is negative 4I1 plus 12I2 minus 2I3 equal to 0. So elaborate this equation. So you got 12I2 minus 2I3 equal to 20. Okay, this one, because we know that I1 equal to 5 ampere. So substitute this one in here. So that's why you got this equation. Right? So next, at loop 3, okay, you got negative 12I2 plus 2I3 minus 2Vx equal to 0. Against, okay, so our equation need to be in current, all are in current, so therefore you need to find what is Vx, right? So look at the circuit. Okay, so this is our Vx over here plus minus Vx over here. So if you see Vx is actually for uh, 4 voltage at 4 ohm, but in the circuit at 4 ohm you have two current flow at 4 ohm, which is I1 and I2 over here. So plus minus Vx over here is actually due to the polarity of the current I1 plus minus. So therefore we can say that Vx equal to 4 I I1 minus I2. Right, so this is equation for Vx. Okay, so we use this equation, right, to substitute over here. So you got uh, negative 2i2 plus 2i3 minus 2. This is 2vx. This is your vx. You got 2 4i1 minus 4i2 equal to 0. So elaborate this equation. You got, finally you got, and then substitute I1 with 5 ampere. So finally you got 6i2 plus 2i3 equal to 40, right? So now the equation that we need to solve is actually equation 2 and equation 3, right? So by solve these two equations, you got I2 equal to 3.33 ampere, and then I3 equal to 10 ampere, and then we know that VTH equal to 6I2. Okay, so 6 times 3.33, so VTH equal to 19.98 volt. Or you can use you can say that is actually uh, near to 20 volts, something like that, right? But both I accept if you give this value. Okay, so next we already calculate the RTH value and VTH value. So at the end we need to draw the equivalent circuit. As we know, this is Thevenin equivalent circuit, so automatically your VTH will be in series with your RTH. So this is your VTH and then this is your RTH, guys. So this is the value that we are looking for. Okay,